Okay, welcome again, everybody. Today we have a talk by Neels on codecs in OsmoMSC, MNCC, and SIP. And I'm handing over to Neels now. Thank you.
Hi, welcome. I'm Neels, working for Sysmocom on the Osmocom stack, and yeah, I've done a lot of work on the past years, and one part of it was changing the way OsmoMSC handles the codecs, because there were a couple shortcomings, and that was a couple years ago already. And the branch is still on the side, and since now things are happening again in OsmoMSC on the codec side, I would like to get back to this branch. And so I offered to first explain what is going on and why. So yeah, let's take a look. So this is a branch merging proposal. So let's first see, like, quite trivially actually, what should happen like on GRAN A, like on 2G. Obviously, the phone and the cell and the BSC, they all have constraints on the codecs they can use. And the idea is to combine all of them and pick one that works. I mean, it's obvious. Shouldn't be too hard, right? And now there's also usually two legs to a call. So to extend this further, obviously, we want to get codecs from both call legs, and then preferably pick one that both sides support. And of course, we could do transcoding. Well, we at Osmocom, we currently can't without an external PBX. But even if you can, you don't really want to do transcoding because it takes a lot of computing power. So it's a good thing to be able to see what both sides can support, and then pick one that that doesn't need transcoding on either side. So we, like this case just now, that was usually I would say that would be the internal call forwarding in OsmoMSC. But let's also look at the more common place where we have an external SIP, like in production setups or on Congress. So we have a call leg on 2G, and then we have the other call leg on a SIP call, and that's going through the Osmo SIP connector and then onto a PBX. So there again, ideally, we would like to get the codecs that both sides support and then pick the best one. And then we also have 3G, where we have IUUP in the RTP payload. And so there usually it's, well, we do IUUP period. But then, like, how do we consolidate all of this? So let's first look at it, like, what do we want? What do we want to happen? So how does the MSC affect codecs? What's going on there? So on the RAN side of the MSC, we have the GSM call control, which is, by the way, the same in 2G and 3G, because the call control messages are in the DTAP. They are not different except for the assignment, which is a wrap assignment on 3G and assignment request on 2G. But otherwise, what the phone tells us in the CC messages, that's the same. Like, that's on the RAN side, and on the core network side, or the PLMN side, we have the MNCC, which is, as far as I know, it's an Osmocom invention, and basically we pass around structs of information about either call legs with MNCC messages requesting a setup or indicating an alert and so on. So those are the both ends that MSC needs to consolidate and marry and work with. Later, I'm also going to mention the media gateway, which is not in this picture yet, but let's first look at the CC side. So what is supposed to happen there? So this is one call leg being set up, and what's supposed to happen in the complete layer 3, say the CM service request or whatnot, we get a codec list of what the BSS supports. So that's the codecs that the BSC has configured usually, or it knows that the cell, the BTS, supports this and that codec, and it combines those things and tells the MSC about it. And we've been at the like in the old days, we didn't even send this codec list from OsmoBSC, now as from like our BSC, but we've added that many years ago, and this list is being sent. And next up, we need to know about the phone itself, and that's told to us by the MS bearer capabilities. We get this in the CC setup. So the phone tells us what it can, and the BSC tells us what it can do and allows. And what we need to do is combine those and pick our favorite one, put it in the top, and then send out the assignment request. And in there, we send a channel type, and then later we get told which codec was chosen. So what does this look like in detail? Okay, yeah, so just a summary, that's what should happen. And in the current MSC, we basically ignore the codec list that the BSC imposes. We read the phone's bearer capabilities, but that's the only thing that we use, and we don't really order it. And also in the assignment request going out, the speech codec list is derived from the channel type, so obviously it's not ordered. And yeah, so that's what it currently looks like. And so let's just look at in detail what do we want to make this better? What do we need to do? What do we have to achieve? So at first, in the complete layer 3, the codec list looks like this. It's like a checklist of some codecs that can be used, and it's the GSM 0808 speech codec type. And the next one was the bearer capabilities. It's also a checkbox list of things that are supported. It looks pretty much the same or exactly the same, but it's a different definition. It's this one was 4808, and this is 2408, and different paragraphs. So it's a different definition, basically saying the same thing. But you know, fair enough, we can translate it. And obviously, what we want to do is we take these both masks and basically bitwise AND it, and we are left with the codecs that both the BSC and the phone support. And so that's what we can do. And then an assignment request, we send out a channel type, which is yet a different definition of the same thing. There's a bit more to it. We select speech and we say, yeah, we would prefer a full rate channel. And then again, we give this, again, this bit mask of codecs. And this time it's a permitted speech, yet another definition, but you know, whatever, we can deal with that. And so where was I now? Oh yeah, and then in the assignment request, there's also the speech codec list, and it's a sort of a duplication, but it also reflects the preference that the MSC wants. So like here, I didn't put X's but numbers to indicate that, you know, we would prefer AMR, and then second up, we would yeah, be fine with GSM FR. So that sounds fairly okay to implement, not much problem there. And as soon as we get the assignment complete, the cell and the phone, they have chosen one codec, and then we stick with that. And that's an important detail to remember in the discussions to come. Right, so the other side, we just talked about the RAN side, so now let's look at the PLMN side, where we talk MNCC. So this is, even this, in this chart, when I have the two MSCs at the top, even this could be the internal MNCC, where both sides, they don't know much about each other besides the MNCC information. So that's sort of an API abstraction in OsmoMSC, where we can also transparently switch to external SIP. So same thing. What do we have there now as of today is in the setup indication, we send out our bearer capabilities, and the other side sends us their bearer capabilities, and that's how we communicate the codecs. And the bearer capabilities is the same as the phone sent us. So again, it is again the same, basically the same list, and we can imply some ticks and send it across. And now, what about this step currently? Well, I'm not so sure about the internal, but at least in the Osmo SIP connector case, we completely failed to send this list of this checked list of codecs, or at least in the Osmo SIP connector, we failed to translate that to SIP codecs completely. So, and on this side, do I have a SIP one? Yeah, on this side, for example, at Congress, we had to hard code a GSM codec in the Osmo SIP connector code, which is not very nice. And no, it doesn't really seem such a hard thing to translate this this mask to SIP codecs, right? So talking of SIP codecs, how does SIP represent codecs? And enter the session description protocol SDP. Maybe you've seen it. And that's what it looks like, a text-based protocol. It has the IP address. So I'm often confused which is which. I think one is just the entity that manages the call, and the other is the RTP IP address, and the RTP port is over here. And then it configures a list of codecs. And this one, for example, it allows these numbers, 112.3, 111, 110, and defines those as AMR, GSM full rate, GSM half rate, and EFR. So, I mean, this looks like a much more general representation of codecs than a list of ticks, because here we are also future compatible, or we could express codecs that are not part of the GSM land. And so SDP seems pretty nice. So SDP, speaking of which, don't I see that somewhere else too? Yes, of course I do. SDP also is used in the media gateway. Sorry, I'm still recovering from a cold. Might be even COVID, though the tests are negative, but I'll cough a little bit every now and then, which is also why I prefer not to share my camera at the moment, because I guess I don't look at my best. Anyway, let's just continue with this. So we talked about SDP on the SIP side to represent codecs, and now look at that. What's this? We also have SDP in the MSC already. We talk SDP with the media gateway to set up the both media gateway endpoint connections. Right, so on a CC, we have bearer capabilities, permitted speech, speech version, whatever, whatever they came up with next and again, a lot of weird combinations of codec selections. We talk MS bearer capabilities on MNCC, and here in the SIP, we talk SDP, and to the media gateway, we talk SDP. So, why not also add SDP on the MNCC? So that's the basic idea that would allow us to close the gap and limit the weird tick mark lists to the CC realm, and from the MSC on, just talk SDP for codecs. And let me peek at my slide here. Oh yeah. So so then we could just pass through the SDP, like what the SIP tells us, what it can do. and we consolidate that with the phone, and then basically the result, I mean, it makes everything simpler if you don't translate so much. So let's quickly look at SDP a little bit at the media gateway, what's happening there. So you have two cons, and what SDP is basically you assign to a payload number, a payload type number, you assign a codec, and you have two sides. So how we use it is on both sides we configure the same codec, usually also with the same number. And then RTP packets indicate which payload type they contain, and 3 gets forwarded as 3 and backwards. So there's not much interesting stuff going on there. But what's also possible is to configure a number of codecs. So we could add AMR to this list of possible codecs, and then technically, whenever either side decides, they could just also, switch to AMR and just suddenly start sending RTP packets with a different payload type, and then that would get translated over to the other side, and the number would indicate the type of payload. Right, so what is also possible is to have different numbers on either side. So you define a codec, but on the one side, you assign a different payload type number. And then what Osmo Media Gateway does is, or what the Media Gateway in general is supposed to do, is translate the one number to the other and the other number to the first one in the reverse direction. So just to illustrate the sort of things that become possible when we know more codecs. And what we actually, as far as I understand, what we do with the IUUP is that we even do some sort of transcoding in the media gateway now, where on the one side we configure IUFP, or where does this IUFP come from? In my world, it's called IUUP, but whatever. I see Power added this IUFP constant to the list of codecs in the media gateway client. So I took this on. So we define IUFP on the one side, which is IUUP inside the RTP payload, and then the media gateway unpacks it, and if I understand correctly, does some magic with the payload, and on the other side we drop out AMR. So here the media gateway is configured to transcode from IUFP to AMR and back. Not sure how far it is there. Maybe Paul can talk about that later. But that's like what's so nice about using SDP, that we can be a lot more flexible with what codecs we configure where. So what's the aim? We have these 3 types of codecs, the 2G and the 3G on the left, and the SIP one on the right. And we want to use SDP to communicate codecs between those, and also we want to fix the use of the call control. And so shouldn't be too hard, right? And so now I want to explain how I did this, and what this implicated, and then how the patch ended up being a bit more than it should be, or like rather a bit badly readable, or not as readable as it should be, because there's some stuff going on. So let's see. This is a ladder chart of a full voice call, and I generated that some time ago from OsmoMSC logging output. So this is what really happened, and it's pretty long. It has both codecs. So let's just first look at the top left here. So in the CM service request, oops, okay, I can't mark the text in the PNG, obviously. In the CM service request, this comes in the layer 3 complete message, and there we get the BSS codec list, like the selection of the BSC and the BTS, incidentally. And then stuff's going on up until the CC setup. So up here, we just need to remember this the BSS codec list. And later on in the CC setup, we also get the MS bearer capabilities, as I said before. And then we need to mangle and combine that. And then, bam, here's the first MNCC going out to the remote codec. And then I would like to add SDP here because we already have figured out what codecs this side can do or wants to do, and then let's tell the remote side about it. Okay, now SDP, right, has an RTP port number in it. So, Dan, we don't have it yet at this place, at this time, because the CRCX, well, the RTP port is given to us by the media gateway after we ask it to open an RTP port, and that we do by the CRCX. And as you see, the CRCX and the current master code only happens afterwards. And now, how shouldn't be too hard to just do it before. So I thought about just sending RTP port 0 to begin with, and I don't know. Maybe we know the IP address already, or like whatever. I thought about maybe not changing too much about it, and maybe sending the RTP port, the proper one, later. But then I thought it's not so hard to just do the CRCX a bit sooner, and then already have a fully functional SDP going on in the setup end. So what I did in the patch, hope you can see this, the change. Now the CRCX comes first, and as soon as it's done, that's probably just because of the ordering in which the code is written. So actually this CRCX affects the setup end because now the port number is known. And we also create the other side CRCX, the other side's endpoint a little bit sooner. Usually it would only it's even stronger. Like in the current master case, the core network CRCX is even down here. Just now I was pointing at the RAN one, which is not even the interesting one, but this is the interesting one, the core network CRCX. I move that all the way to the top, and now let's skip to the branch again. So here we are on the branch, and the core network CRCX is done first, and the RAN follows suit. Why is the RAN here? Because of the assignment command, it needs the port number. Okay, so now this would all be in the order that we need to have port numbers and codec information ready. And now this part is moving the CRCX, obviously changes a lot of the sequences in the MSCA code, and how one function calls on the next and then expects an answer to come in later on a different callback and so on. So this made a bit of a messy patch situation where code bits move around or new functions get created, and then later on to also put the codecs in code that was moved was also changed, and now this makes for a really ugly patch to read. So yeah, that probably went a bit wrong there, and I should have done it more duck steps like. But also at the time I was writing it, I thought, oh, there's not much time really. This is more a thing on the side, and I was working fast, and just why not this and that, and this is how it works, and bam, there I was with this huge code bomb. And now I'm working on untangling it again. So let's see. Yeah, now my idea is to show a bit of the code of what's happening, and then I have a few thoughts of topics that I haven't mentioned in the way they deserve yet, because not all is good and perfect in the new patch, but there's still some open things. So let's just look at this Codecs branch. You may notice before, this Codecs branch was just a huge patch and a little one following suit. And this single patch, yesterday I split it up in this more or less meaningful subtasks, and basically to audit the code and understand what's going on, but it was actually quite a bit of work to unspaghetti it. So there's a couple of not so interesting stuff going on in the beginning. The first interesting one is this one, where I add the codec SDP to call control translation. T9N means translation. So let's just quickly look at this. So before I talked about all the different representations of codecs, those tick lists and radio button lists and so on, and the SDP one. And here what this actually is, I hope you're familiar with the patch notation. So here I just add two files, and the first one is a header with a couple of definitions. Let's skip this. The interesting part is this. So I make this data structure, which is the codec map. Each line is a codec mapping, and it tells you what SDP name corresponds to what payload type number and which MGCP constant we use in the code. And then for PCMU or PCMA, obviously we don't have GSM equivalents, but here's the GSM full rate codec, which usually has the payload type number 3. It corresponds with the speech version this, and the speech codec type that, and the permitted speech constant that, and it also I don't really remember this. I guess this says whether it's full rate or half rate, and for GSM FR we obviously need full rate. So this is how it goes on. There's just a mapping where the utility functions that follow can convert one to the other or add one to it. It's not really that interesting, just basically written down. Now the interesting parts here is that, for example, I have AMR twice. Not really sure about this, how to take this into the future, because the AMR also has configuration settings going on, the octet align one, which apparently we always need in GSM, and we also have mode sets. So I have these two kinds appearing, and basically added another one for, if we're looking for this, we also want to find AMR. But if we're looking for AMR, we will just get the first one. And I'm not sure about the symmetry or like what it should be like, but there's some hidden pitfalls in there. But currently, it works. Also added AMR wideband, though I never saw it used. Anyway, so this is all the codecs I could find, we use, and added this to this matrix basically. And
is the IUFP one there?
It should be. I added it somewhere else. So one part that it's not here in the branch. Why? Because we merged it a long time ago, because I even started merging this branch, and currently it's dead code. It's the SDP message. Wait. What? Oh, I have the other one still open. Anyway, open read only. Yeah, just shown. So it's where are we now? Okay. Oh, that's the right one. Yeah, okay. So it's this API that defines an SDP message. So obviously we should already have representation of SDP in the media gateway, but unfortunately it's very convoluted with how the media gateway is written, and it was really hard to pull it out. So instead I made this new file and copied some code across. So the core of it is this SDP message, which says what is the IP address and RTP port reflected in it. This p time thing. I don't know what that's for. And then the list of audio codecs. And seems to me I limited to 16. I don't know where this number comes from. Could probably also be dynamic, but it seemed simpler at the time. So each codec has an SDP subtype name, a payload type number, a rate number, and possibly some format character. So that's the other API that's already there. And then I use both of these to implement this, the Codec Filter. I renamed it because originally I took a stupid name that no one can understand. Codec Filter is much more simple to understand. So wait, just look at with Codec with code highlighting. Codec Filter. Yeah, just open it. Yeah, it's fine. Right, so the Codec Filter, it's quite easy to see. Is what I had in the slides, all the different sites, well, this is what was in the slides, the MS-Bearer capabilities, the BSS codec list, what the remote codec can support, and which codec we selected and basically committed to as using. And also added is what the RAN can support, whether there's 2G or 3G, or, like in principle. So we will not have, I don't know what's a good example. We will not have GSM FR on the IU interface, for example. So this one would already filtered out. It's a hard-coded thing. And then you run this magic function filter run, and then you get the resulting codecs in this result, which is always based on the two APIs that I mentioned earlier. And then you basically get an SDP message where the codecs that remain, that all participants can use, they are listed. So if we already selected one codec in the assignment, then that's the only one that remains. If we don't have a remote yet, that doesn't limit it. Like that's how it works. Basically, what you put in gets filtered, and then you get the result out. And then basically all that's left is collect all of this information, then like wherever it's appropriate, and this resulting SDP, just send it out in all the MNCC messages we send to the OsmoSIP connector, and from the OsmoSIP connector forward the SDP, and then as we receive it, we store it here and run the filter again, and that's how the MSC can figure out what codecs it should use, or it likes to pick. So wait a minute, you asked about Codec Filter, no, about IUFP. Now, where did I add it? Okay, yes, exactly, I remember now. So I added this IUFP here, but that's a bit special, and I guess, let me just quickly see. Yeah, I'm talking about this later, so let's just hold this for now. And that's basically dealing with the 2G stuff. Right, so starts very simple. In the call control transaction, we just add one of these codec filters. So this one will always collect what's happening. And so in the complete layer 3, when we receive it, remember it happens first, long before the call, the CC setup. So we just have to store it. That's what this patch does. Really simple. And also, by the way, our BSS map coding, it actually didn't care to decode it. So that was already merged years ago in preparation for this branch. That we even get the codec list BSS supported from this. From here, like from the BSS map message definition. So I don't know, let's just continue. So then what's happened here? Okay, so the mobile originated call. So that's when it starts, when we set up the codec filter, put the run type limitations, put the complete layer 3 limitations, and since this call is starting, we already got the CC set up. We add the MS bearer capabilities, run the filter for the first time, and then I also added a lot of these, where it just says what's the current codecs status. And so that's the mobile originated call, mobile terminated call. Same thing where the MNCC tells us to set up, we initialize, yada, yada. Not much to talk about here without boring you. And then what also happens is, hold on, is it this one? Oh, it's the next one. Anyway, later on, we get told the MS bearer cap store. This again, lots of details, no need to talk about this. And then there's another thing in the assignment complete, like way after everything happened, the BSS again tells us the codec list that it supports. And I guess the intention there is to, I don't know if it changes from earlier, but definitely this codec list is used to also to select which channels we can hand over to. So I guess that's why it's there again. Maybe after a codec was picked, the BSS can again tell us, at this point we can hand over only to whatever, another AMR codec, or So we also remember that, and possibly put it to use, because once it's stored, like in the BSS part, we store it, then we can use it later in handover. Right, and now another thing here is that I also put in this patch a bit over eagerly maybe is, so remember I told you that each media gateway connection can have multiple codecs configured. And as I was writing the code, all of our code, what we use is more like this. There's only one on both sides. So I started off adding code which always picks the first item in the list. I mean, for a simpler patch, that's obviously, the right step. It should have been there probably first, and I should have done this other part a bit later, I guess, from looking at it from this perspective. But what I did was I already enabled the RTP stream struct, or the entity, which is the one representing the media gateway con, like one side of it. I already added capability to, just have not only one codec, but keep a list of codecs that we tell the media gateway. So that's also already in the patch. And yeah, that's basically this patch. Store multiple codecs and allow sending them to the media gateway. And there's just a lot of effect coming from it, because every place has to, suddenly handle multiple codecs instead of one. But at the intersection where we get our result from the codecs filter, I mean, it's very nice. We just tell the RTP stream, these are the codecs, and then, tell everyone about it. Right, and then, so, I'm not really using this, really putting multiple codecs in the MGCP, but, basically we are ready to have SDP connect from the SIP to the media gateway with this. So that's why I say it shouldn't really have been necessary now, but here we are. Right, the next bit is tell the MNCC about it. So it's just some preparation. Like the most interesting part is probably here, just the setup is an MNCC struct, and what happens is we just put the SDP string there from the SDP, which comes from the filter result. So we run the filter, take the list of codecs and cast it into an SDP string, and actually send this string over here to the MNCC. And well, what I didn't mention also, this ability to add MNCC, to add SDP to the MNCC was also merged already years ago, and we already even bumped the version numbers of the MNCC between MSC and SIPCon. So it's already being sent back and forth all the time just is empty. So all we need to do now is just add the information because the protocol already supports it. And then there's something else yet, I don't know, to specialize. Just, you know, when the remote side sends us bearer capabilities, do what, I don't know, store, on send the CCR bearing, I don't know. This is some detail, I don't need to talk about this. And then this other patch, which I said is ends up a bit convoluted, the one that puts the core network CRCX first. And, you know, let's just quickly skip over it. You see lots of, you know, new function headers being created, which was formerly one function is now two, and it's doing this and expecting to be called back later, and, you know, things getting shifted around, and, you know, probably one or two, all three odd things that aren't necessarily trapped in there. So I guess sorry about that. But if we want to get on with this patch, we probably, you know, maybe I should spend some more time looking through it. Okay, so you know, just for illustration, this is the diff on the test outcomes from the MSC VLR test, and here, for example, is a new log line being added, which tells us about the codecs that we have in this test. Let me just scroll to the right. So it says the RAN can support these, the phone supports these, and I don't know why really, I guess because the way the tests are written, the result is only AMR. I think, I don't know, maybe after the assignment it's fixed, something like this. So that's basically, that's how you can follow around in the logs. Here's another one, how the codec situation changes. Maybe the log line is a bit long, as always with the code that I write, but at least, you know, you can have a chance, if you're not using Wireshark, you have a chance to read exactly what's going on. Where am I now? Right, so that's the bulk of it. And then what's also nice is this is the sequence chart we had just now. So I updated that so you can see how it changes. Then I had a bug and added a little flag. No need to talk about this. And this is also pretty nice in the MSC VLR tests because this just runs much quicker. I added tests for, let me see where the test definitions are. I guess these are them, is like testing, for example, both codecs pick AMR and then, you know, configure which side sends what, and then expect a resulting codec, where would that be? Anyway, you know, expect an assignment and certain list elements to appear. So there's a couple of tests that verify that. Actually, it's only 3. That's a bit, or 4. I don't know. Either way, so with these tests, I verify that, you know, I wrote sensible code that picks up all the ends and combines them, filters them properly. So that's also nice to know that I tested this. And what's that? Just a comment, not important. So that's for the code. So I guess this one is the worst to review. The do CN CRCX first. But as I said, this was not all about it. Here are the sequence charts I was talking about. So thoughts that I still have and important things that weren't mentioned yet. So what my branch also needs is a patch on the OsmoSIP connector. And in that patch, so far I just forward the STP 1-to-1. So I don't change anything about it. And that was fine at the time I wrote it, but in the meantime, Keith added call hold support. So in MNCC we have a hold indication, and the patch from Keith, when it receives the hold int in the SIP connector, it switches the SIP to send only. So the SIP does not receive RTP anymore. And so at this point, it modifies the STP. So there was STP from the MSC earlier, and then we're required to take that and just modify this attribute. And obviously, that's not the same as this. And maybe I can quickly show you why I mentioned this, because let me see if I can find it quickly. So here's the one, the STP create file that creates the STP. What my patch does, just return the STP and none of this, decoding, encoding, yada, yada. So basically, I have to destroy Keith's patch with the current version. I mean, obviously, we could also decode it and encode it again and add this mode that he added, the send receive or receive only or send only modes, but I haven't gotten that far yet. And why am I mentioning it? Because I'm wondering how it should work. Maybe the SIP connector shouldn't even care about this at all, and maybe this should even go directly through to the MSC. And yeah, and wait, I'm getting mixed up. So maybe the MSC should care about this, because then the MSC can also maybe tell the phone or the BTS to stop sending RTP when it's on hold, or something like that. So and also we have the case where the call control sends a hold, but I'm not sure about the other case. What if the SIP initiates a hold? Because there's no such thing as an MNCC hold request. So that's probably something we still need to talk about before we can, drive this patch home, or maybe, drive this patch home in the way it is now, because maybe we think it's worth it, and then fix this whole thing later. Yeah, so we should probably talk about this. So it's one thing to talk about. And the other thing is, wait, I thought I'd taken these out. And, well, I haven't anyway. So, yeah, that's not important. I'm going to skip this. The thing that I think is really important is the consolidation between the codecs. Because all of this talking I was doing now, all of this patch and all of the stuff I worked and did and so on, it was all still about the one codec, either the, actually basically the MO codec, let's say MO or MT codec. So it's all on one call leg, and even if we send the STP through and we have it here, then there's still something to do here, because what should happen, obviously, the mobile originated side should pick its codecs that it supports. Then we get the same from the mobile terminated side. We combine the two, and tada, we get a list of codecs that both sides support, and then we pick the favorite one of those, and then we have a situation without transcoding. Now, what currently happens, even on the after the patch is applied, after my branch is applied, what happens is the mobile originated side picks the codec, sends it to the terminated side, and then it's pure luck whether the MT side also supports this codec. What's so bad about this is that maybe the MO side supports AMR and EFR, I'm just making this up, and then the terminated side does support EFR but not AMR, okay? So there would be a codec that both could agree on and have no transcoding, but because the MO side just picks a codec first, it maybe picks AMR because it's the favorite one, and then the mobile terminated side doesn't even get its word in. So even though they could talk on EFR, the one side picks AMR, and then we're stuffed. We need to transcode, or in a pure OsmoCom setup, we would just give up and refuse the call because we don't have transcoding. Right. So, but what needs to happen for this? Currently, I showed earlier in the sequence chart, we first do the assignment on the MO side and have a fixed codec. and only then we tell the other codec about it. So there's no chance of, getting the other remote codecs in. And what I would like to do is two ways to do this. Like the first idea I have is don't do an assignment at first. You just figure out the codecs, tell the remote side about it, and then the remote side has its local preferences, and like the mobile terminated side has the MO side codecs and its own. Then it picks the codec. So in the previous example, this would pick EFR, and then send this back to the MO side. So instead of letting the MO decide, rather let the MT side decide on the codec, and then it's magically a common one that both support. So that would, before I shifted the CRCX to an earlier place, then I would again shift the assignment to, all the way to the bottom. And that would probably again make a patch where lots of things are unreadable. But, that could be one solution. The other idea I had is do an assignment and pick a codec. But instead of just sending the one picked codec, we send all of them, the assigned one, we put that first as the preferred codec, but all the remaining ones that would also be possible, we also add this to the SDP. And then the MT side can, pick the one we already assigned if it supports it, or it can just pick a different one. And then we tell the MO side which codec we actually chose. And if necessary, then the MO side can do a mode modify or a reassignment, which actually now we do support. We recently implemented that code path, and it works pretty well in the wake of implementing Vamos in OsmoMSC. So this actually, it looks like a good option now, and both have like a disadvantage here. The disadvantage here is that we do an assignment pretty late, so maybe it takes a bit longer for the call to establish, because the MO side, when the MT side is ready to talk, the MO side still needs to set up a channel, and then possibly also, say the BSC refuses assignment, then we have wasted resources on the MT side. Like we told it to assign, even though there's no LCHAN even available to assign on the BSS, and we only find out later. So that could be a bit of a drawback. And here the drawback is that if we have mismatching codecs, then of course we do more signaling than necessary, because we already did the assignment earlier and now we do it all over again. But the more I think about it, maybe this is even easier to implement, and this only has a disadvantage if the codecs mismatch. So you can even, with configuration of the network and the PBX, you can even avoid this overhead probably. But still, if it's necessary, you can do it. So that could be interesting too. Sorry that I'm pulling boxes here. It's kind of a habit. And, when I'm looking at presentations, if someone does it, it pretty much annoys me, because I like to put my eyes where I put them, and then this guy keeps pointing at things. Sorry about that. Anyway, but you are tempted to do that giving a presentation like this. Right. So those are the biggest parts, and I thought, this is why I added this. Well, actually it isn't, but let's just, let's find a different slide to talk about the IUFP quickly, because that's the one. POW. So what's special about the IUFP? I mean, looking at the branch yesterday, I added IUFP to the codec list, the definitive codec list of translating one to the other. But here we have a special situation, because how we usually use it is like this. We have we pick the codec to use. Like there's just one, we pick GSM, and then we tell both cons to use GSM, right? And it's not like we have any code that could decide to, maybe transcode to AMR or PCMA or whatever, because we don't do transcoding. So we always have the same codec on both media gateway.
Yes, if
codes.
I may add, implementation-wise, I think I saw also that we in MGW we are actually storing the codec. We are storing it at endpoint level. So I think we can basically, implementation-wise, we cannot right now have different codecs because it's not stored by connection. So yeah.
Oh, really? Okay. So maybe that just quickly, since you mentioned it, what I wrote here in my patch. It's the SDP message one that we added a long time ago. The commit log actually says this API is added to probe whether it works, and when it does work well, the intention is to move it to the media gateway and use this representation everywhere there. So there was a plan. I already know that the media gateway has some slightly weird implementation choices, and maybe
yes,
it makes sense.
I agree. I also noticed that all the codec handling in libOsmoMGCP client looks a lot cleaner than MGW itself. So yeah, I mean that needs to be improved. I agree. And yeah, you talk regarding all the mappings between the port. The payload types in RTP and all that. Yeah, it was quite illustrative, let's say. So thank you.
Yeah. Okay. So now what I still want to talk about here is like a different situation. And in IU, in UTran IU, we still have CC coming in from the phone. It still says us, this MS bearer capabilities where it supports these and those AMR modes, right? And so so how do I explain? So first in the patch, I added IUFP as a first-class codec, say, and then I was faced with the situation where the code would want to set IUFP on both sides, or it doesn't have this idea then that IUFP and AMR are essentially the same, and so then I rolled back a bit of the changes and did what you did, Paul, in your patch, is basically just let OsmoMSC figure out that it wants to use AMR everywhere, but just basically at the last point where we tell the media gateway what to put in these cons, at that point, hard code IUFP in there when it's on the UTran IU interface. So
well, it really depends, I guess. Like on the run side, so on the run side connection of the MGW, you probably always want to use IUFP if like the subscriber is coming from UTran. So because it's going to be that way,
yes.
Unless I'm wrong. So, but yeah, the point is when basically you want to breach the two legs on the CN side connection.
Say again, if you want to reach the two legs.
So basically, you have the two legs at the
bridge.
yeah, like using, for instance, one MSC. Basically, you end up with the connections reaching the MGW attached to the MSC on two different endpoints. And basically, at the later point, what you want to do is basically to bridge those two legs so they can talk together. And at that point, basically, you need to really decide. For instance, if you are calling between 2G and 3G, that means that one connection on one endpoint is going to be AMR, and the other connection on the other endpoint is going to be IUFP. So basically, then you need to decide, so what I'm using here. So then I probably need to configure both to use AMR, so that was the point. But for the other side, so for the other connection side, so the one going to towards the RAN, let's say, it's not an issue because who's the subscriber there. So you can infer.
Yeah, on the RAN we know it's IUFP, and on the other side, and that's what I'm not clear about. You get IUUP or I don't know IUUFP or whatever you call it on coming here on the media gateway, and what I did in my naive patch a long time ago was I just stripped the IUUP header and sent the payload on to the other side. but there's some work going on there that you did.
Yeah.
So, so what's happening there? Do we also change the payload somehow and make it proper AMR,
what I'm
or
doing,
what happens?
I also took some patches from Linksy also. He submitted, and I basically improved them and fixed some stuff. So the point here is that basically, I recommend you, by the way, I shared 2 PDF links just to have a look at them later. I think it will be also a bit helpful to understand better. But anyway, the point is basically that in UUP, we use this SMS PDU mode, it's called, I think, where basically there needs to be this initialization message sent one way and initialization message back the other way, where basically they announce to each other in summary, the AMR mode that they are going to use. Which, by the way, I think you also have that in the MSC. So the point is that when the MSC configures the connection on the MGW, it just tells it, okay, it's going to be IOFP, so you don't need to pass exactly which AMR modes, if I'm not correct, because anyway, the MGW is going to receive that from IUUP itself. But yeah, going back to the topic. So when you receive IUUP, there's some FSMs basically calling back to do all these initialization handshake, let's say. And according to these PDFs I also shared, the links basically, as far as I understand, the expectancy is basically that you kind of terminate the connections from, like you separate the connections. So it's not just forwarding packets from one side to the other, because you maintain some sort of state. And even like you could, since you are announcing the AMR modes and whatever, you could even decide to basically use some subsets or whatever and do transcoding and whatever. So the idea of what I implemented is basically that I really separate the connections on RTP level, so no forwarding at all directly of RTP. Like when we basically have an endpoint with 2 connections, we basically we forward the packet directly. We patch it a bit, but we just send it directly. In here, I'm actually, if it's IOUP, I'm taking the AMR payload from it. These packets also contain a field called RFCI, which is basically an index into a table which was shared during the initialization phase, which is basically a table of AMR mode. So basically this RFCI is basically telling you which AMR mode is this packet. And then I'm taking this AMR and I'm using some functions which mangle a bit the payload to transform it to AMR bandwidth efficient or AMR octets aligned, depending on what's needed on the other side. And then I push that on top of RTP on the other side and send it back. And the other way around, it's similar. So I take the RTP packet, I convert this AMR octet aligned or AMR bandwidth efficient to what I call AMR IOUP. So which is kind of octet aligned, but a bit different. It's basically shifted 10 bits because you have to put some stuff there. And then I send it down the stack of IUUP through all the FSM because it needs some state, and then it sends IUUP on the other side with this AMR payload. So it's not really like transcoding, as in like heavy transforming the payload or whatever. It's just basically shifting 10 bits the payloads. So,
okay. So just to summarize, the way I understand it, it's sounds like you actually fixed properly IUUP. So just first to paraphrase what you said is like we get IUUP on the run side, we strip off the header and take the AMR payload and we mangle it a little bit to become proper AMR, if I understand correctly, and then actually on the other side we send proper AMR. And and just a few anecdotes. This IUUP initialization act, that was, I remember, when we started adding 3G and we had the Nano 3G set up and everything, and I tested and everything was working. All the complicated run-up messages going back and forth, and everything worked except the bloody RTP stream just wouldn't open up. And everything looked right. It was RTP, it was AMR, the bit rates, everything was fine. And actually, that's only when we found out that in IU, the RTP payload is not RTP, but is, there's another header in there, the IUUP, and you need to do some IUP stuff. And so then at first we only had 3G to 3G calls, and we just forwarded the IUUP from the one to the other, and you're not even supposed to do it. You're supposed to terminate both IUUPs and the first hop. But anyhow, so then later on, we hacked something up to strip this IUUP header and just throw it out and just put it back when we receive AMR. And then suddenly we were able to do 2G to 3G calls with 2G subscribers that can do AMR. But it was really weird, I remember on was it on Congress? Anyhow, so when you talk into the 2G phone, you hear it perfectly fine on the 3G side. But when you talk into the 3G phone, then sometimes it sounds right, but sometimes it doesn't. Especially when you take a short break in talking, or it was silent and you start talking. There was weird stuff going on. Like when you stop talking, maybe the last syllable would continue forever, or someone would appear to start talking slower and slower. Really interesting stuff happening there. And so the way that it sounds is that you maybe properly fix the AMR payload.
Well, one of the big issues I found, which basically degraded a lot the audio, is basically that it seems nano 3G, despite IUUP says that you should basically not take into consideration the timestamp in the RTP header. It actually seems to be doing something with it, because I casually, like when I was developing the patches, basically I left that untouched. So the code was setting the RTP timestamp correctly, let's say, based on timing on the computer, let's say. So not perfect, but good. And then I basically removed that because it was not needed. And then that was the day after. And then I started like getting super messy audio with cutting stuff or pinging or whatever. And then I just looked at the previous version of the patch and the new one, and the conclusion was basically, okay, I'm not setting the timestamp, but it shouldn't matter. But then I said it, and I really noticed the change there. So
so somehow Nano 3G orders the packets.
Well, it probably tries to infer, because that's the more I look at IUP, the more I think it's really messy, because I mean, good stuff you have in RTP is basically like you can compare the sequence number with the timestamping, and you even have the M bit, so the marker bit, so you know where you have to reframe everything or resync, and then you can control a lot of stuff there. But you don't have that with IUUP, because you don't have any timestamp field, so you cannot do that kind of stuff. So it looks like using IUUP looks like going backwards. It's like a bit strange.
It is really strange. I mean,
and then
even put the headers in the other
sorry
order.
to interrupt.
I was also going to do that and finish this talk maybe first.
Yeah, thanks.
And so just do I have one overview picture somewhere where I can just quickly mention the things to finish this up? Where is it now? So what I want is fix this part where we properly deal it. As I said, I want to get STP talked over MNCC, and I already properly consolidate the codecs here, but I would also actually like to change this assignment or reassignment thing so that we can also take into account the remote sites codecs. And that's basic, so that we can, that's basically what this talk was about. And let's go to slide 42. Let's hit end there. No, that's end. There you go. Those are the two branches in the current state. And thanks for listening. And I guess we can stop the recording and go to, or maybe questions first that would like to be on the recording. Or Harald, you take over, do the moderation. You're used to that.
Yeah, first of all, thanks for the talk. Also, very happy to see lively discussion and interaction. I think it would be nice to have, indeed, if there are some short questions or general questions before we go into a more detailed technical discussion of what to do and how to do it, and sharing anecdotes and so on later on. So yeah, if anyone has questions that should be on the record, please bring them up now. Thanks. Okay, seems like there are no questions for the record. Then I pause the record. I stop the recording. Thanks.
Thank you.